Hello everyone, and welcome to another video of tutoring. I am Leah, and on my channel you can find more science and math videos. Now today I'm going to be talking about how to draw Lewis structures. In this video, I'm also going to tell you how and when to make your double and triple bonds in Lewis structures. So make sure you stick around to see that. Before we start drawing our structures, I want to make sure that we know some important background information. Here we see a chart of the group numbers and the elements included, and showing how many bonds the elements like to make. So for example, for group 1 here, we have that hydrogen and sodium, and the other elements in group 1 like to make one bond. In group 2, they like to make 2 bonds. In group 3, 3 bonds, and so on. It changes here in group 5 when the elements like to make 3 bonds, and then in oxygen's group 6, they like to make 2 bonds. Fluorine's group 7, likes to make 1 bond, and the noble gases don't really like to bond, as they have their octets filled here. They have 8 electrons and they're happy. Now 2 more things before we start drawing the Lewis structures. First, electronegativity. This is the ability of an atom to draw electrons towards itself and keep those electrons near it. And for the trend here, which is important to know, the trend of electronegativity increases as we go to the right of the periodic table and increases as we go up. So your most electronegative atom will be fluorine. Now for the second thing, valence electrons. For this, the number of valence electrons for an element correspond with its group number. So for example, the elements in group 1 of the periodic table will have 1 valence electron. The second group will have 2 valence electrons for each of the elements, and so on. So for example, if we wanted to find how many valence electrons carbon has, it would have 4. Because it is in group 4 of the periodic table. For oxygen, this would have 6 valence electrons because it is in group 6 of the periodic table. And for lithium, here, because it is in group 1, it would have 1 valence electron. Alright, now we are ready to start drawing our Lewis structures. Here I have outlined a few steps to correctly draw Lewis structures. Step 1 is to count the valence electrons for the molecule. So count the valence electrons for each element that is present, and then add those up so you can find the total number of valence electrons for the molecule. The second step is to decide which is the central atom. Now, generally, the central atom will be the least electronegative atom in the molecule. Step 3 is to start connecting the atoms to the central one. So you have to start making bonds. Step 4 is to subtract the used electrons from the number found in the first step to find the number of valence electrons left. So that means that after you have done step 3, after using some of the valence electrons, you want to make sure you know how many are left. And then once you know how many are left, step 5 is to put pairs of the remaining electrons around the outer atoms and then on the central atom, if there are any left. So any remaining electrons here will go first on the outer atoms, and then on the central one. Finally, for step 6, when appropriate, make sure that the atoms fulfill the octet rule. So make sure that the atoms have their outer shells filled, or they have 8 electrons in their valence shell. And one more thing I want to add is that a lone pair here, or the pairs that you will be drawing in step 5, are like this, just 2 dots. And when we connect atoms, we draw lines between them. So we'll have an atom here, and this line here will represent 2 electrons. Alright, now we are ready to start drawing Lewis structures. So for example, let's find the Lewis structure for CH4, also called methane. So our first step is to count the valence electrons for the molecule. So for carbon, we have 4 valence electrons, because it is in group 4. And then we have hydrogen here. So hydrogen has 1 valence electron. However, because there are 4 atoms of hydrogen, we want to multiply 1 times 4, which will give us 4. So we have 8 valence electrons in total. Now we decide which is the central atom. Now because hydrogen can only make one bond, we know that carbon has to be the central atom. We know that carbon has to be the central atom so that 4 other atoms can connect to it. Now for step 3, we start connecting the hydrogen atoms to the central one. So we have hydrogen here, and another one here, and the fourth one. Now for step 4, we subtract the used valence electrons from the original total. So here we have 4 bonds here, 4 lines, right? And we know that each line represents 2 electrons. So we have used 8 electrons. That means that we have no more electrons to use. So we do not have to do anything for step 5 because there are no remaining valence electrons. Now step 6 says that we should make sure that the octet rule is fulfilled. And for carbon, we see it has its 8 electrons here in the form of these 4 bonds. And for hydrogen, we know that its shell is filled. The reason that hydrogen's shell is filled here is because hydrogen can only make one bond. And once it makes that other bond, that is all it can make. So it will not have 8 electrons, it will have 2 maximum. Now let's do another example. For HF, hydrogen fluoride. Step 1 is to count the valence electrons for the molecule. So for hydrogen, here we have 1 valence electron because hydrogen is in group 1. And then for fluorine, because it is in group 7, we have 7 more. And we add those up. So we have 8 valence electrons in total. Step 2 is to decide which one is the central atom. Because there are only 2 atoms in this molecule, it doesn't really matter which one is the central one, as they will just be connected together as such. So step 2 and 3 here are pretty much done. Now we want to make sure that we know how many valence electrons are left. So with this one bond, we use 2 electrons. So we will subtract 2 from 8, which will give us 6. Now we have 6 more valence electrons to go, and we'll just distribute them around the fluorine atom, as hydrogen can only hold a max of 2 electrons. And now that we have redistributed our remaining valence electrons, the structure is complete. Fluorine is happy because it has its octet filled, as does hydrogen. Notice that hydrogen only has the 2 valence electrons shared here, and that completes its octet. And for fluorine, it completes its octet because there's lone pairs here around it. And it has the one bond here that is shared. It applies to both of them. Now, for Cl2, we want to draw the Lewis structure. So step 1 is to count the valence electrons for the molecule. So chlorine is in group 7, which means each atom will have 7 valence electrons. So that's 7 times 2, which is 14 valence electrons in total. Now, we have step 2 and 3, where we just connect these atoms, and then we subtract the used valence electrons here, which is 2, and we have 12 valence electrons left. And as you know, we just put those valence electrons around the atoms. So here we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And so we have no more valence electrons left. And now we can check in step 6 that we have fulfilled the octet rule for both of these atoms, which we have because there are 6 valence electrons here for each of them, and 1 shared pair of electrons, which applies to both of them. So each atom has its 8 electrons. Now let's do another example, or boron trifluoride. So for step 1, we want to count the valence electrons for the molecule. So for boron, we have 3 valence electrons because the atom is in group 3. And then we have fluorine, which has 7 electrons, which is times 3 because there are 3 atoms of fluorine. So 3 times 7 valence electrons, and we add those numbers. So here is 21, So 3 plus 21 is 24 valence electrons we have in this molecule. Now, for step 2. Decide which is the central atom. Now, as we saw in the beginning, fluorine only likes to make one bond, just like hydrogen. And we know that boron likes to make 3 bonds. So we know that boron is going to be the central atom. And if you look on the periodic table, you will also notice that boron is the less electronegative atom here. So step 2 is done. Boron will be our central atom. Now for step 3, we connect the fluorine atoms, the outer atoms, to the central one. Step 4 is to subtract the used valence electrons from the number found in the first step. So here we know we used 6, as each line here equals 2 valence electrons. And so 24 minus 6 is 18 valence electrons we have left. And so we distribute these 18 electrons first on the outer atoms. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. So we have no valence electrons left, which means that we don't have to worry about putting any valence electrons on the central atom. And so this would be the Lewis structure for boron trifluoride. Now for this next example. Make the Lewis structure for CH3, CH2, CH3. Now for this formula here, we have to count the valence electrons for it. So here we know that we have 3 carbon atoms, and we know that, so 3 carbon atoms times the 4 valence electrons of each carbon, and we have to add the valence electrons of hydrogen. So we have 3 atoms of hydrogen here, plus 2, plus 3, which is 8. So 8 times 1 valence electron for hydrogen will be the total number of valence electrons from hydrogen. So here it's 12 plus 8, which is 20 valence electrons. Now this is a structural formula which tells you in what order the atoms will be bonded together. So first we have a carbon here attached to 3 hydrogens, and then we have another carbon attached to 2 hydrogens, and then we have a third carbon which has 3 hydrogens attached to it. And this is the Lewis structure for this molecule. And if you want to double check to make sure we used up our valence electrons, we can. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We have 10 bonds here, and as you know, 10 of these bonds is equal to 20 valence electrons, which means we have no more valence electrons to use. So this one was nice because it just told us in what order we should make the bonds with carbon and hydrogen. Next one, carbon dioxide, or CO2. So as usual, step 1 is to count the number of valence electrons for this. So we have carbon, which has 4 valence electrons, plus oxygen's valence electrons. So oxygen is in group 6, so that means 6 valence electrons. However, there are 2 atoms of oxygen, so we must multiply by 2. And that will give us 16 valence electrons. Now, because carbon is the less electronegative atom, it is going to be the central one. And then we attach the outer atoms to it. And then we figure out how many valence electrons we used, which is 4, which gives us 12 valence electrons left to work with. As you know, we redistribute those around the outer atom. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And now we don't need to worry about putting any more remaining valence electrons on carbon. However, when we check step 6, we notice that carbon here doesn't have its octet filled. It needs 8 electrons to have its octet filled, but it only has 4, as shown by these 2 bonds that connects it to oxygen. And so what happens here is that a lone pair from this oxygen will go here, and a lone pair from this oxygen will go here. So that in the end we have a double bond between oxygen and carbon. And now, if you look at this again, carbon does have its octet filled. It has those 8 electrons. And oxygen does as well. We have 1, 2, 3, 4, and then we have the remaining 4 in these shared bonds here. So that is when you make double bonds. It's when the octet of the central atom is not being filled, and you have to put the lone pair and convert it into a bond between those 2 atoms. Now let's do another example. Let's find the Lewis structure for NH3. Step 1 is to find the number of valence electrons for the molecule. So we know that nitrogen, because it is in group 5, has 5 valence electrons, and then we add the 3 times 1 valence electrons for hydrogen. 1 meaning that hydrogen brings 1 valence electron for each one of its atoms, and we multiply it by 3 because there are 3 atoms of hydrogen. And this gives us 8 valence electrons. Now, as you see here, as we saw in a previous example, because hydrogen only makes 1 bond, we can't make hydrogen the central atom. We have to make nitrogen the central atom, because nitrogen likes to make 3 bonds, and we know that hydrogen can only make 1 bond. So there's no way we can attach 3 other atoms to a hydrogen atom. Alright, so now that nitrogen is our central atom, we can connect the hydrogens to it. So we have a hydrogen here, here, and here. And now we calculate how many valence electrons we used. So for 3 bonds, we know we used 6. So now we have 2 valence electrons left. And as you know, the rule is to put the remaining valence electrons on the outer atoms. Now, because hydrogen can only carry 2 electrons, we don't put any extra electrons on any hydrogen atoms. We instead put them on the central atom. And now we have used our 2 valence electrons left, and we have 0 left here to use. Now, hydrogen has its shells full because it has its maximum of 2 electrons here in these bonds, and we know that nitrogen here with 2 electrons here and its 3 bonds carrying 2 electrons each, that nitrogen's octet is also filled. Here we have HCN. So the first step is to count the number of valence electrons. For hydrogen, we have 1, plus the 4 from carbon, plus the 5 from nitrogen, which gives us 10 valence electrons. And again, of course, we find the number of valence electrons for each element by looking at which group it is located in. Now for step 2, we determine which is the central atom. We know that hydrogen will be eliminated because it can only make 1 bond. So that leaves the competition between carbon and nitrogen. Now, seeing as carbon is the less electronegative atom, we know that carbon will be our central atom. And now we attach the hydrogen here and the nitrogen. Doesn't really matter if the hydrogen is on the left or right, or if the nitrogen is on the left or right. Alright, so now we look at how many valence electrons we used. In these 2 bonds, we know that we used 4 valence electrons. Subtraction tells us that we have 6 valence electrons left to use. Now with 6 valence electrons, we know that we have to put them on the outer atoms. But of course we know here that we cannot put remaining valence electrons on a hydrogen atom. So we have to put them on the nitrogen. So we have 1, 2, 3, 4, 5, 6. And so we don't have any more valence electrons left. Now for step 6, let's double check that our octet rule is fulfilled. So we know that hydrogen is fine because it has its 2 maximum electrons for it. And here for nitrogen, we have 6 here, and we have the shared pair, which adds up to 8 electrons for nitrogen. For carbon here, we have 4 valence electrons in it, and we know that that is wrong because it needs 8. So what we do, like in the other example, is that we take these lone pairs and place them here until carbon has its octet filled. Now by placing here 4 more electrons here, then we know that carbon will finally be happy. We can here count. There are 2 here, and then there are 6 here. So carbon has its 8 electrons. And here for nitrogen we have the 3 bonds here, and we have the 1 lone pair. So there are 6 in these 3 bonds, plus the 2, which means that nitrogen also has its octet filled. Thank you so much for watching this video. Please let me know in the comments if you found this video helpful, and please remember to subscribe if you are new. I'll see you next time.